Hey everyone, you're not going to want to miss this episode of the AI Show, where we are going to be talking about combining the power of vector search with function calling in Azure OpenAI service. Let's jump in. Today, we are joined by Derek. Welcome, Derek. Thank you so much for hanging out with us today. Why don't you tell us a little bit about yourself and what you do?
Yeah, thanks for having me on the show, Cassie. So my name is Derek Legenzoff. I'm one of the product managers on the Azure OpenAI service.
Awesome. And today, you're going to be going over some really cool things with function calling from the Azure OpenAI service. For people that aren't familiar with what that is, can you tell us a little bit about it?
Sure. So what function calling really does is it enables you to use these new versions of GPT-3.5 Turbo and GPT-4 and be able to create structured outputs. And what that really enables you to do is be able to connect these models with other kind of tools or systems you have. So, for example, you might want to connect to your search index, like we'll be showing you late in this video, to be able to retrieve data and augment your prompts, so you can leverage that in the prompt to be able to get those answers. Oh, or you can also use it to add additional capabilities to the model. So, for example, these language models really aren't that great at math, but now you can create a function that maybe is a calculator or does calculations that are important for your use case. So, it really can help kind of augment the capabilities of these models, and for scenarios that might have been difficult with just these models on their own.
Awesome. So we're going to learn how to do that then, right? You're going to show us how we're able to augment the model to better serve different scenarios that we need and make it better at things that maybe out of the box it's not great at.
Exactly. So, this is we're kind of building off of the AI show that Liam did last week, where he created an index using vector search. So now, what I'm going to show you how to do is actually use function calling to be able to query that index, and we'll actually kind of throughout this video kind of be building a little chatbot to help you search for recipes and find a good recipe to make. And we can actually even leverage the capability of the model to help maybe tailor that recipe or come up with replacement ideas. So hopefully we'll be able to show kind of a nice little end-to-end scenario of how you can use function calling for a real world scenario.
That's awesome. Let's take a look at how we can do that.
Sure. So I have a Jupyter notebook here set up, and up here I'm just importing some libraries and defining my credentials for both my Azure Cognitive Search Index, as well as my Azure OpenAI service. Um, and then next, what we want to do is actually kind of define the messages we want to send to the model, as well as the functions. Um, and if we look at this function, there's a few key things we're going to provide. So we're going to give this function a name. So in this case, we want to be able to query recipes from our Azure Cognitive Search Index. So you've named the function that. We're just going to give the model a few details about what this function is designed to do. So we're pretty simply just saying it's going to retrieve recipes from an Azure Cognitive Search Index. And actually, this description will actually be added to the kind of the prompt behind the scenes. So this is almost like a new style of prompt engineering, where within this function, we're giving details and teaching the model how to use our function. Because these new versions of GPT-3.5 Turbo and GPT-4, the 0613 versions to be precise, have been fine tuned to learn how to use these functions. And then within the call, we're actually going to teach it to use our particular function. We're also going to give it the parameters. So in this case, I've defined a pretty simple function. It just has one property. It's a query. That's a string. We're going to describe that it's the query string to search for recipes. So then I've also defined my user message. In this case, I'm just a simple prompt saying, "You help me find a good lasagna recipe." And now what I can do is I can send both those messages and the function to the model, and the model is actually going to determine if we should make a call to this function or not. And if it does determine we should make that call, then it's going to actually give us the JSON that it thinks we should use. So here we can see it's actually proposing that we call this query recipes function with the query term lasagna. And actually from there, the idea being that you would go and then what you do is you take the string, convert it to JSON, go and then actually call that function, get the results, and then send another request to the model.
And so the query string that's being returned is the query string that's going to be sent to our Azure Cognitive Search, right?
That's exactly right. Well, in this case, now that Azure Cognitive Search has vector search, what we can actually do is you convert this query to an embedding and send that embedding as a query, so we can get even more accurate results.
So
Um,
it's now helping us figure out what we want to ask our search index to get what we want returned, right?
That's exactly right. So
It's
like
so cool. Sorry.
essentially with function calling, like you can define a variety of functions. So here we've just defined that one, but we can have a bunch of different functions. So what the model is really able to do is determine, based off the context of this conversation, if we should call a function, and then how we should call it. So you can really be able to do a lot with these capabilities. Um, oh, go ahead.
As the developer, do I still decide when it's called though? So it's suggesting that I call it, but I still control that the call is made, correct?
Exactly right. So
Okay.
with function calling, we're not giving the model actual access to these systems. All the model is ever going to do is kind of generate this query, and then from there, you as the developer can take this. You determine if you actually want to make that call. You validate this response and actually go and then make that call on the model's behalf and everything.
Very cool.
Cool. So this is a fairly simple example here, and let's imagine for a second that we're building a chat bot to help you find recipes and you help you make something good for dinner. Um, so we could also try like another example of maybe we're looking for a Mexican recipe that has beans and rice in it. So we can try that, and we can see now it's able to convert that to a query as well. But as another example, if I'm using this chatbot, I might just say something fairly simple like, what should I cook for dinner? And in this case, the model does a pretty good job based on the context of giving it. It's trying to query for dinner. But if I have a search index of recipes, this might not be a particularly useful query. So what I could actually do is do a little bit of additional prompt engineering and actually add a system message to give the model a little bit more context about what
Mhm.
I'm trying to really do here. So let me just paste in the system message I prepared ahead of time. And so essentially now I'm just telling the model, hey, you're an assistant that's a large language model designed to help users find and create recipes. You have access to an Azure Cognitive Search index with hundreds of recipes. Um, and then the other thing is like in the case of this dinner, I really want it to be interactive. If I say, hey, help me cook something good for dinner, I want it to kind of carry on that conversation and help me come up with ideas before it actually goes and issues that query. So now I'm telling it, hey, you're designed to be an interactive assistant. You can ask users clarifying questions, help them find the right recipe. So now after I add all of this in, when I go ahead and send this request, now it's going to determine, hey, I'm not ready to call this function yet. I need to get more details from the user. And now it responds, sure, I can help you with that. Could you please let me know if you have any specific preferences or dietary restrictions? And this is a fairly simple system message. You could always add more details to try to give it a little bit more personality and stuff like that. But you can see you pretty immediately with just a few sentences, we're able to kind of completely change the behavior of the model.
I'm thinking to myself, and I think you've just automated like, half the conversations married couples have, but what should we have for dinner? So we can just let the OpenAI model help us figure that out and suggest something. And now we've saved ourselves a lot of time. I'm trying to figure out what we should have for dinner.
Yep, totally. I'd honestly love to use something like this by myself. When actually, one thing I find when I'm trying to cook is I might have like just a few like maybe I have like broccoli
Hmm.
and tofu around or something, and it's like
Yeah.
I need to find a recipe that has those things. And so this function we've defined currently is fairly simple. It's really just we're just passing in a query, and actually within Azure OpenAI service, we now support Azure OpenAI on your data, which actually makes it really easy to do this retrieval augmented generation pretty much like out of the box. So what I wanted to show is actually how we could make this function a little bit more sophisticated, actually tailored even more to our use case. So I've
Yeah.
defined like a slightly more complex function that does a little bit more that we might want to do in this use case. For example, so we still have that query string, but now I have an ingredients filter where if I list ingredients like beans and rice in my recipe, I want to actually be able to explicitly add a filter. So in addition to this vector query that we're going to be sending, we can also add explicit filters in Azure Cognitive Search to kind of trim down the results. And one thing that's kind of interesting here is so Azure Cognitive Search has a specific syntax for being able to filter. So actually, within this, we need to teach the model how to create like appropriate filters for Azure Cognitive Search. So I need to teach it, what are the names of my fields? What does that syntax look like? And so in this case, in the ingredients filter, um, I say this is an OData a filter to apply to the ingredients field. Only actual ingredient names should be used in this, and then we give an example of what this filter should look like. And I also have another field like if you're me, a long work day, I usually just want something that I can cook in like 25 minutes or less. So I also added a time filter, so that we can filter down based off of the time the recipe would take. And actually, before I dig in any further, I should probably just show you kind of what an example recipe looks like in the search index, so you can kind of get a feel for it. Yeah,
Mhm.
so we'll have a category, recipe name, the full recipe itself, the description, and we have like that list of ingredients and that total time. So we're essentially using these two fields now to be able to filter down a little bit further.
And those are the static search things that are going to be sent in along with the vector.
That's exactly right. And actually, in just a second, I can show you kind of what the model will generate for these filters. So now I can try that same query I tried before of find an easy Mexican recipe with beans and rice, and it should hopefully be able to create those filters for us. Now we see the query is Mexican, so we're going to be able to search for all like Mexican type food. We have that ingredients filter. Whoops. So it's going to filter down to only recipes that like explicitly mention beans and rice. And we've also added a time filter where it's going to look for recipes that the total time is less than 30 minutes. And actually, with that, I did bake in kind of a little bit of like business logic into this here too, where I explicitly told the model like if someone's asking for easy or quick, let's filter down the recipes that take less than 30 minutes. So we can really kind of add a lot of logic into this function call to make the model perform how you want it to.
Very cool. So we're really describing what we want in the JSON call so that it can make an accurate request.
Exactly. And so you get kind of the full flexibility to define this however you want. So you can do kind of prompt engineering within this function call, within your system message and all that stuff. So you can really, tailor that behavior so you can find the most relevant results for the user and kind of give them that experience that they're looking for.
And from like a way that you would implement this in an application, um, you're setting all this up right now and we're testing it and we're kind of iterating through it. If I was going to be putting this in an application feature, would I be sending in this system message and function every time I start a session with the model?
Yeah, great question. So yeah, like normally when you're using these models with Azure OpenAI, you're going to include the system message in every request, and then you'll also kind of keep a running list of the user and assistant messages. So like in this case, I'm just showing you kind of that first message, and we're always just setting that one user message. But traditionally, what I'll show you kind of towards the end is we can kind of continue on the conversation and add the previous messages into this array. Um, and actually, what I've showed you so far is really just showing you kind of how you can be able to um, you know create you get the function call from the model. But I think what I'd love to show you next is how we can actually go and kind of string all of this logic together and actually kind of then be able to retrieve the recipes from the search index and then you get those results.
Cool.
Um,
Yeah.
so I've defined this function called generate embeddings. This is a fairly simple function. You're just going to pass in a string, and then we'll get the embedding back. And so we're going to use that. So every time we send a query to the search index, we'll first use Azure OpenAI service to get that embedding. That we're able to do that vector search in Azure Cognitive Search. And then I've also defined a fairly simple function for calling Azure Cognitive Search. I'll pass in that query, pass in my filter. So I have a little bit of logic here just to join the filters together properly. Um, and then now I'm using all the bells and whistles in Azure Cognitive Search. So I'm using vector search here, like you're mentioning earlier. I'm also using hybrid search because I'm still sending in that the raw string. Like in this case, the string was like Mexican, and that way you kind of keyword results and the semantic results. And like I think the one example I love to give there is like if you searched like ice cream, vector search is really good because it's going to be able to get you results on like ice cream, frozen yogurt, gelato. But if you only got results on frozen yogurt and gelato, you'd probably be a little bit upset. You want to see some ice cream results too. So I think hybrid is really good because it takes advantage of um, those keywords as well. And then we're also leveraging semantic search, which I know Liam talked about in his video. So we're kind of leveraging all the bells and whistles of Azure Cognitive Search here.
Awesome.
Um, and then and then so the last thing I do is so the model is going to return so Azure Cognitive Search is going to return a bunch of JSON. But what I really want to do is I want to kind of take the text from Azure Cognitive Search and put it in a format where the model is going to understand it well. So what I'm really doing is I'm looping through the results here, and then I'm going to kind of print out the recipe ID, the recipe name, and the description of that recipe. That's what we're going to kind of give back to the model, so it can use that to kind of inform its response to the user.
where we're at so far is that you have uh, told the OpenAI model what you want it to assist with. It's giving us a JSON result with suggestions based on a prompt that we sent in. And then from there, we're parsing that out. And now we're going to query cognitive search to get back from our index recipes that would fit that. Correct.
That's exactly right.
And then are you going to take that and feed that back into the OpenAI model? Or is that just going to be displayed to the user or what's next?
That's exactly right. Actually, so right below this, I kind of have the logic all to stitch it together. So now that I define that function. So I've defined the function in the prompt. So now I need to actually define like the function we want to call when that gets triggered. So we define that function to call Azure Cognitive Search. So now what we need to do is we need to stitch all this logic together. So I wrote this run conversation function. We'll send that that initial call to the model like we were doing up above. And then at this point, we're going to check if the model tells us to call a function or not. And then if it does tell us we need to call a function, um, then we're gonna get the function name, make sure we like that's a function that we actually are able to call. Then we'll go ahead and actually call that function and pass in the arguments. And just for demo purpose, when we run this, I'll print out like the function call. But then once we get the results from the function call and everything, what we'll do is we're gonna append that back into this array of messages that we have, and then make another request to the model. And then that's how we're going to kind of get this final response from the model. So now that we've defined the function to call Azure Cognitive Search and this run conversation function to kind of go through that process, what we can do is you have defined the system message again, and now we have a new query. I want to make a pasta dish that takes less than 60 minutes to make. So let's go ahead and run this. We can kind of see the end-to-end flow here. So we can see we got the function call like we'd hope. It's querying. It wants to query for pasta and filter down to recipes that take less than 60 minutes. That looks perfect to me. And then we can see the results that we got from Azure Cognitive Search. We got pesto pasta and some other recipes. So now at this point, what we needed to do is kind of then you take this function call, take the output function call, and use that to send another request to the model. So you can see now we're about to send another request, and you can see kind of all the details that we now have in the prompt. And then when we send this, we're going to get this final response from the model, where it's going to kind of take this data we give it and kind of really give it to us in a nice, natural language way. So here are a few pasta dishes that take less than 60 minutes to make, gives us those options and everything. Well, and now that we have the basics working here, we can actually take a little bit further. Like one thing you might notice is it's not actually telling us how to cook these recipes yet. And if you had a
Yeah.
UI, I'm sure you could just make these hyperlinks and kind of handle that in the application layer. But I figured like might as well show how we can let the model be able to do this as well. So what we could do, we had this one additional query recipes function, and actually one thing to call out, in my testing, I found out the ingredients filter was actually a little bit too rigid. So like if we filtered down to beans and rice, a lot of times it might say like brown rice or white rice, and then my filters were a little bit too explicit for that. That's actually where vector search is super useful, where it's going to be able to do kind of like it's not that semantic similarity and be able to find stuff. So I've actually kind of taken out that ingredients filter for now, and we're just going to leverage this time filter because that one did work really well for my scenario. And then I've defined a couple more functions as well. So one is a fairly simple function to go ahead and get the recipe. Is essentially we're going to take the recipe ID, which we gave to the model in the previous function call, and the model can use that to go and look up the full recipe. And another one, like I don't know about you, but I don't get to spend quite enough time cooking, so I'm not really good at like recipe like measurement conversions. So I thought it'd be nice just to have a function to kind of give some new capabilities to the model where it's going to be able to convert these different measurements and everything. So if you don't have any like clean teaspoons around, you can figure out what the appropriate number of tablespoons is, stuff like that. This is another fairly simple function where we're going to pass in the amount and like the original unit and the unit we want to convert it to. So the same thing, I've defined these functions in code as well. Actually, Copilot Chat helped me create this one, which was super nice. And then we have this get recipe function that we pass an ID. We can see that we're able to get that full recipe back. So now we can try this one more time just to test out these new functions. So if I say you get details in recipe 124, and obviously a user wouldn't quite do that, but just to show that the function's working, we can see it's able to do that. Or if I were to ask it like to convert like how many cups is 2 tablespoons of butter. We can see that it's able to generate that correct function call for us as well. So at this point, we've kind of gone through the whole development process of of getting this all wired up. Do you want to
Mhm.
see the thing running end to end? See if we can help it find
Yes,
a dinner recipe for us.
absolutely.
Great. So I've stitched all this logic. I've kind of copied and pasted all this logic over into this run recipe chat function. So just go ahead and run that, and now we'll be able to give it kind of a few messages and kind of have that true conversation. Let's start with something simple. You'll help me find something good for dinner. To this point, we taught it that it should be prompting us to come up with some ideas. So now it's asking, do you have any cuisine or ingredients in mind? So how about this? How about some Thai food that I can cook in less than an hour? And just so you can see that you've gone ahead and kind of printed out, so it's searching for Thai, and total time is less than 60 minutes. And then we can see the recipes it came up with. So it's proposing your Thai peanut noodles, Thai cashew tofu stir fry, and so on. And then we can see kind of the response from the model. And maybe reading through this, the Thai peanut noodles sounds pretty good. So now we can say, show me the recipe for Thai peanut noodles, and we can see it now. It prints out that full recipe for us. We get the name, description, details on like the prep time and everything, and the ingredients, and then those instructions. You see it's printing twice. Just one is the function output. The other one is the actual response from the model. Um, but let's say now, like it's asking for rice noodles. I don't have any rice noodles on hand. So one nice thing is, in addition to using these functions and be able to query Azure Cognitive Search to get our data, we can still leverage all the knowledge of the model to help us have this really useful assistant. So maybe I say, are there any good alternatives to rice noodles? And now it shouldn't be calling a function or anything. It's just going to actually leverage the knowledge of the model itself and give us some ideas of we could do soba noodles or udon noodles or zucchini noodles. So we're able to kind of combine both what's in our search index and what we've kind of groomed there, but also be able you combine the power of the model to really create a nice interactive chatbot to help us find exactly what we're looking for.
So we went over a really cool example of how you can leverage Azure OpenAI Service and Azure Cognitive Search to create a recipe assistant with really not that much code. Super cool to do. Where can people go recreate this and learn more?
Oh, well, so first, I'd recommend you can go check out the blog and documentation on vector search and Azure Cognitive Search to learn more about how to get up and running with that. In addition to that, you can check out the documentation on function calling and Azure OpenAI. Within that documentation, we'll link out to some sample code that will show you similar end-to-end patterns of how you can define some functions and then kind of get things running end-to-end to be able to really build out that experience that you're looking for.
That's great. So this is all stuff they can go do right now.
Exactly. All of this is publicly available. Both vector search and Azure Cognitive Search and function calling and Azure OpenAI are in public preview. So you can go ahead and start playing, and we're super excited to see what our customers build.
That's great. Thank you so much for hanging out with us today and showing us these neat features.
Thanks for having me on the show.